Welcome, folks. A couple of you have pointed out that there are kind of some gaps in the notes for Unit 10, and that I really, uh, as far as materials goes, I really haven't put up a lot to help you with sections 10.6 and 10.7. And so that's going to be kind of the purpose of this video lesson is to give you everything that you need to know for 10.6. This lesson I'm anticipating is going to be a little bit longer. My next one should be a little bit shorter because once you guys learn this, 10.7 should be pretty easy. It's just kind of like a minor adjustment to what we're talking about today. Okay, so first we're going to talk about the unit circle. I've got that up here. This is essentially identical to the one that should be in your notes already. Then what we're going to do is talk about some patterns on the unit circle and why those patterns appear. So why do certain values repeat on the unit circle? We're going to start with these values right here. You'll notice that if you pick a point either to the right, top, left, or bottom on the unit circle, so that's at 0 degrees, 90 degrees, 180 degrees, and 270 degrees. All of those degree measures, the point will have 0 or 1 for their coordinates, right? So we've got 1, 0, 0, 1, negative 1, 0, 0, negative 1. And this is because the unit circle has a radius of 1, right? So if you measure from the center to the edge, that's 1 unit. And all of these points are either on the x or y axis. So this point is on the x-axis, so it has a value of positive 1. This point is on the y-axis, so the y value has a value of positive 1, and so on and so forth. Okay, and then it's worth noting that these values satisfy the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse of the triangle. So for all values on the unit circle, because the radius is 1, your hypotenuse is going to be 1. So c squared is going to be 1. And then x will just be the x coordinate of the point on the unit circle, and y will be the y coordinate. And so, like if we look at our first point, 1, 0, 1 squared plus 0 squared equals 1, right? Because 1 squared is 1, and 0 squared is 0, and 1 plus 0 is 1. And we can kind of do the same thing with all the other points. So 0 squared plus 1 squared equals 1. Negative 1 squared plus 0 squared equals 1. That's this point right here. And then if we go down to our bottom point, 0, negative 1, 0 squared plus negative 1 squared also equals 1. Okay, let's look at kind of some other patterns that we see on the unit circle. If we look at these points at 45 degrees, 135 degrees, 225 degrees, and 315 degrees, they all have square root of 2 over 2 for both of their coordinates. So each coordinate will either be square root of 2 over 2 or negative square root of 2 over 2. Okay, so where does that come from? Well, if we draw a 45-degree triangle, right, at 45 degrees, and then we know that the hypotenuse of our triangle is 1 because the radius of the circle is 1. And we know because this is a 45, you can probably figure out from geometry that this top angle is 45 and this angle right here is 90 degrees. So this is a 45, 45, 90 triangle, which means that it's isosceles, right? That means that this bottom leg is going to be the same as the top leg. So normally we call them x and y, right? Like the coordinates of this point right here would be x comma y, right? This point right here. But because these are the same length, we can really call them x and x. and then we can use that and the Pythagorean theorem to solve for the lengths of these legs. So we can say x squared plus y squared equals 1, right? That's the Pythagorean theorem on the unit circle. But really, these x and y are the same length, so we can really say that x squared plus x squared equals 1. If we combine like terms, we can say that 2x squared equals 1. Then we can divide both sides of the equation by 2. And we'll get x squared equals 1/2. And then to solve for x, we will square root both sides of the equation. And that will give us square root of 2 over 2. Well, where the heck did that come from? Why does the square root of 1/2 equal the square root of 2 over 2? Let's show it right here. Square root of 1/2, that's the same thing as square root of 1 divided by the square root of 2. The square root of 1 is just 1, so this is just 1 divided by the square root of 2. In math, historically, it was a bad idea to leave a radical. The square root of 2 is a radical. It was a bad idea to leave that on the bottom of a fraction because the square root of 2 is an irrational number, and historically they did not have high-powered calculators like we have right now. So if you wanted to solve this for an approximate value of this fraction, you would have to take 1 and then divide that by an irrational number by hand, which is very, very difficult to do. So what mathematicians used to do was a technique to get this square root out of the denominator. And they would multiply by the square root of 2 over the square root of 2. The square root of 2 times the square root of 2, that's the same thing as the square root of 2 squared, which is 2. And then 1 times the square root of 2 is just the square root of 2. If you want to leave your answer like this one right here, I'm fine with that. Just know that on the quiz, all of your answers are going to look like this. I will have simplified the denominator. So you have to know that this answer is equal to this answer. Okay. Another set of values that we see repeating on the unit circle are square root of 3 over 2 and 1/2. And we can see them at 30 degrees, 150 degrees, 210 degrees, and 330 degrees. And for all those, the x value is either going to be square root of 3 over 2 or negative square root of 3 over 2. And the y value will be 1/2 or negative 1/2. Okay, let's talk about where that comes from. For that one, I'm actually going to start with an equilateral triangle, and the side lengths on this triangle we're just going to say are 1. If I cut it in half, right, so I take my equilateral triangle and I chop it in half, now this will become a 30-degree angle over here, and this side length will be 1/2 because I cut that side in half. And so then we're going to solve for this unknown side right here. Okay, let's put that on our unit circle right here, right, at 30 degrees. Okay, now let's set it over here. Again, the hypotenuse is 1 because that's the radius of the circle. This is 1/2 because we cut that equilateral triangle in half. And this is x. This is what we're going to solve for. Again, we're going to use Pythagorean theorem. X squared plus y squared equals 1. X squared plus 1/2 squared equals 1. X squared plus 1/4 equals 1, because 1/2 squared is 1/4. That's just 1/2 times 1/2. Subtract 1/4 from both sides. We get 3/4. X squared equals 3/4, so now I'm going to take the square root of both sides of that equation. When I do that, I will end up with x equals the square root of 3 over 2. Okay, again, you might be asking, well, where the heck did that come from? why does the square root of 3/4 equal the square root of 3 over 2? This one's a little bit easier to see, but I will show where it comes from. So square root of 3 over 4 is equal to the square root of 3 divided by the square root of 4. And the square root of 4 is simply just 2. So this becomes the square root of 3 over 2. Okay, so that's for 30, that was for 30, 150, 210, and 330. You might have noticed, though, that at 60 degrees, 120 degrees, 240 degrees, and 300 degrees, we also see 1/2 and square root of 3 over 2, but they're just sort of the opposite way around. Now the x coordinates are 1/2 and the y coordinates are square root of 3 over 2. Well, this is again going to come from our equilateral triangle. So here's our equilateral triangle. You can see I drew it a little bit different this time. But again, I'm going to cut it in half. So this 60-degree angle right here is going to become a 30-degree angle. And that bottom side, which was a unit of 1, is now 1/2. Okay, so I'm going to take this triangle and put it on my unit circle at 60 degrees. Okay, and now I'm going to show how we end up with the y value being square root of 3 over 2. It's the same way as before, essentially. X squared plus y squared equals 1. 1/2 squared plus y squared equals 1. 1/2 squared is 1/4. Again, this should look really familiar to the last one. 1 minus 1/4 is 3/4. And then we'll take the square root of both sides and end up with, oh, whoops, I said y equals there. Here, let's fix that real quick. I said x equals there. It should say y equals. Okay? Right, and again, that if you want to know why the square root of 3/4 is square root of 3 over 2, just go back up a few slides and look at my explanation there. Okay, so values of sine, cosine, and tangent of theta. That's what this symbol right here is. That's the Greek letter theta. So here we've got a triangle that would be on the unit circle. And so we're always looking for a point that's on the unit circle. And so a point has an x and a y coordinate. And so this is kind of like the triangle that we can make with any point on the unit circle, where the hypotenuse of the triangle is 1, and then the x coordinate of that point would be this leg, and the y coordinate of this point would be this leg. And then we've got an angle here that we call theta. So theta is the angle measure. It can be in radians or degrees, and we'll talk about both. Okay. All right, so the sine of theta is the opposite over the hypotenuse. All right, this should just be a review from geometry. So if we look, the opposite of this angle is y. The hypotenuse is 1. Y divided by 1 is just y. So what this means is if you take the sine of any angle, that will tell you the y coordinate of that point on the unit circle. Similarly, since cosine is the adjacent, which is x, over the hypotenuse, which is again 1, and x divided by 1 equals x, the cosine of any angle will tell you the x coordinate of that point. And then finally, tangent is the opposite over the adjacent, so that's y over x. This doesn't really simplify, so we'll just say that the tangent of theta equals y over x. Okay, so then we're going to use these values as well as our unit circle to determine the values of different trigonometric expressions. Okay, so I have a whole slide of examples here. You can see I think I have 24 different examples, although you'll see I kind of made it easy on myself since some of these are going to be the exact same value. Okay, so let's start with the sine of 90 degrees. So we're going to go to our unit circle, and then remember sine is the y value, so at 90 degrees the y value is 1. So then we can just say the sine of 90 equals 1. You can just use your unit circle to answer this. Sine of 120 degrees. Okay, so now we're going to go to 120 degrees on our unit circle, and we can see that the y value of that point is square root of 3 over 2. Sine of 330 degrees, that's down here. That y value is negative 1/2. Okay, so now sine of pi over 2. Well, if I give it to you in radians, your unit circle is going to be a real tool here because pi over 2 is just 90 degrees. Right? Those are the same thing. So again, you just look for pi over 2. The y value is 1. We already did that one, right? We already did the sine of 90. 120, that's the same thing as 2 pi over 3, right? So again, these are going to have the same y value, square root of 3 over 2. And 11 pi over 6, that's the same thing as 330. So again, this is going to be negative 1/2. Okay, now let's do cosine. Cosine, we're looking for x values now, not y values. Cosine of 45 is square root of 2 over 2. Cosine of 180 is negative 1. All right, we're just looking for the x values. Cosine of 300, so now we're going to go to 300. We can see that our x value is 1/2. And again, we should get the same thing when we look at these angles in radians. So pi over 4 in radians is right here. So that, again, is going to be square root of 2 over 2. Cosine of pi, that's over here. We can see that that's negative 1. And it's the same thing as 180. And then 5 pi over 3, that's the same thing as 300. And we can see that that's 1/2. All right, now let's do tangent. Tangent is just a little bit more involved than sine and cosine because remember, tangent is y over x. So we're going to have to do a little bit of calculation with tangent. So tangent of 30 is right here. So my y value is 1/2. My x value is square root of 3 over 2. So I'm taking 1/2 divided by the square root of 3 over 2. That's the same thing as 1/2 times 2 over the square root of 3. So I've just taken this out of the denominator and flipped it. So this became 2 over the square root of 3. The 2's will cancel out. That will leave us with 1 over the square root of 3. Again, we don't leave radicals in the denominator. So we multiply by square root of 3 over square root of 3. Square root of 3 times square root of 3 is 3. And 1 times the square root of 3 is the square root of 3. Okay. We're nearly done at this point. So we can say the tangent of 30 is the square root of 3 over 3. Let's do the tangent of 225. This one will be a little bit easier to evaluate. We get negative square root of 2 over 2, comma, negative square root of 2 over 2. Negative square root of 2 over 2 divided by negative square root of 2 over 2. So again, we can kind of like flip the denominator. So this is going to become 2 over the negative square root of 2. The 2's are going to cancel out. The negative square roots of 2 are going to cancel out. So really we're just left with 1 for this one. So the tangent of 225 is 1. Now let's do 270. That's down here, 0 and negative 1. So I'm going to do negative 1 divided by 0. If you take negative 1 divided by 0, remember, you are not allowed to divide by 0. That is an undefined operation. So we can say that this answer is undefined. Whoops. And then I've already got the next one in here. I didn't mean to. So this one, again, at pi over 6. That's right here. That should be square root of 3 over square root of 3 over 3. When we calculate that, that's the same thing as 30. All right, 5 pi over 4, that's the same thing as 225, so that's going to end up being 1. And 3 pi over 2 is the same thing as 270. That one's undefined. Okay. And then that's how you use your unit circle to answer these. I'm also just going to briefly talk about how can we evaluate these in Desmos. So let's go to Desmos here. I'm going to use the scientific. Well, you know what? Let's get them both open. Let's use the graphing calculator and the scientific so that you can see the difference. So here I have the graphing calculator. Here I have the scientific. First thing you need to know when you're computing these in Desmos is you need to pay attention to whether you are in degrees. So right now this scientific calculator is in degrees. Now it's in radians. Okay, and for the graphing calculator, whether you're in degrees or radians is determined right here. So right now it's in radians. I think this one's in degrees. Let me double check. The easiest way to check, well, we know that the sine of 90 should be 1, so let's type that in. Sine of 90, and we get 1, so yes, we are in fact in degrees. Okay? So that's really nice when they work out to be nice values. Like we can do the sine of 330. We get negative 0.5 or negative 1/2. Here, we can even turn it into a fraction if we want to. Negative 1/2. Right? And that's what the sine of 330 should equal. It's less useful when we get an answer like this because Desmos won't spit out the answer like that. Let me show you what I mean. Sine of 120. Well, we get this kind of like long decimal here. We wanted to get square root of 3 over 2. What if we type in square root of 3 over 2? Well, that does equal 0.866. So they are equal, but that's not going to be a lot of use for you on your key formative because I ask for exact values on your key formative. Something to just be aware of is that if the answer is an irrational number, Desmos won't give you the answer. They'll give you like an approximate answer, but they won't give you the exact answer, which is what your key formative quiz is looking for. Okay, we're going to leave it at that for today, and you can do the same thing with tangent and cosine. So here, let me just show one of those real quick. Like if I do the tangent of 270, you can see that that's undefined, just like it says on here. Tangent of 270 is undefined. I can do the same thing with cosine. If I do cosine pi over 4, I got to be in radians, I get this answer, which just happens to be equal to the square root of 2 divided by 2, right? So we can use Desmos to kind of calculate all of these. just note that if your answer is supposed to be an irrational number, you're going to get a long decimal, and it's kind of up to you to figure out what that decimal is. So it's important that you know how to use your unit circle to answer some of these problems. Okay, so hopefully this clears some of this up for you. Reach out if you have any questions, and I'll do my best to answer them.